So welcome to Robotics 1. As I said, this is an intense course. Attendance is required. You need to come to class every Monday. You need to come to lab every Saturday. Unless you have a valid university excuse, you cannot miss a lab. If this schedule does not work with your commitments, my strong recommendation to you is drop this course and take MAE 547, which is an equivalent course offered at Tempe campus. And that does not involve any playing with the robots or any lab. So it's purely a programming based course. So labs are absolutely required. There is no, question? 2.5 hours. So the lab typically would start dot at 9 o'clock, should end at 11:30. 11:30 you close out. 12 o'clock the next group will come. 2:30 the group will close out. 3 o'clock the next group will come. 5:30 that group will close out.
There's multiple times you can go to the lab.
No, you will be assigned one time, and you have to come to that time only. You don't get to choose time. You assign time.
Okay.
Yeah, Morpheus said to Neo in Matrix, problem is the choice. Don't give any choice. Why red pill or blue pill? There is only red car pill on this way. Okay, all right. So we are going to talk about the robotics, forward kinematics, inverse kinematics, controls. We will also use all these concepts. I'm going to also talk about how to use robots in digital twin. My students will also talk about the advanced topics in robotics, like how the LLM can be used for task decomposition, automated program generation, and robot control via voice prompts. So there is a lot of information going to come to you, and this would be worth your while. But you have to come and attend this course completely. Objectives: understand kinematics, dynamics, and control of robot. If you go to YouTube, all the slides, all the lectures for this course are already on YouTube. So if you are like a self-starter or self-learner that you want to go ahead and learn whatever material is out there, entire course is already on YouTube. Then how to succeed? Don't cheat, don't copy, don't plagiarize, do all the assignments. There would be in-class exams. There will be take-home exams. There would be some certifications. For example, I'm going to ask you to do MATLAB certifications. You should do those certifications and upload those certificates on your LinkedIn. That will give you a significant visibility in terms of employability, internships, and job opportunities. Check your ASU email regularly, and you are welcome to utilize additional videos. There is a fabulous web series which is called RoboGrok. That's also a wonderful series. You are welcome to take a look at it. So the distribution is assignments that include homework, coding, MATLAB courses and certification, 20%, labs, 30%. Each lab would have a lab report and some sort of demonstration. So you basically, the graders or the instructional aides will check out on your lab. You can't just send a pretty report generated from ChatGPT and expect to get a good grade. They will make sure that you have done the lab, you understand the lab, and they check out. And quizzes, there will be in class and take home. There would be a project, and 10% is for attendance. Just for today's class, I'm not taking attendance because I did not tell you in advance that attendance is required. But from next class onwards, next lab onwards, there will be attendance. Attendance will be taken by my student, and they are very smart. So basically, they will, I guess, they will run the sheet, or they will come up with a barcode scanner, or they will scan your IDs. I don't know what great things they'll come up with, but they will take the attendance, and that attendance will count for 10% of your grade. Grade appeals, course evaluation, syllabus disclaimer. I also gave you the detailed schedule of what material I'm going to cover, and I also gave you the link to the video recordings, the videos that I have already recorded, related to that content. So you are welcome to watch those and come prepared to the class. Plagiarism will not be tolerated. There is again academic integrity statement, disability resources, and if you need any help related to the material, you are welcome to send me an email. I typically I don't have office hours, but I would be there in the lab, so you can talk to me on Saturdays, uh, and then you can ask me any questions that you may have. Okay. So, any questions?
Regarding the quizzes, like they will be in class and
Take home.
the take home one is like you give the problem and you solve it.
Yeah, I will give you a quiz that you can take home and work on it. Either you can work on that quiz as part of the group. Sometimes you can use Chat GPT, because even if I tell you not to use, I'm sure you will use it. But I will form the problem in such a way that if you use Chat GPT, I would know that you use Chat GPT. But there would be in-class quiz. In-class quiz would be open notes, closed book, closed laptop, closed phones, and you just use your notes. So make sure you have all the notes that we discuss in class, do the homeworks. And I haven't thought about if I should have announced or unannounced, but I'm thinking one quiz every week would be good.
Yeah, so in terms for the lab, do I can I have the preference of teaming with some people or don't want to?
No, no. Your people and my people are our people, so don't worry. So you don't have choice. You will be assigned in a group, and then in the group, you are welcome to select a partner. So, and who knows, my students will actually shuffle the partners as well. They are smart. They have gone through the drill. So I'm telling you, they are very smart. The school that you study in, they were the headmasters. So, so yeah, they are very good. They will make sure that you get fantastic educational experience. Yeah, what's up?
Sir, in the syllabus you have mentioned that you'll be using MATLAB and SolidWorks. So should we be having a laptop with the recommended operating system?
Yeah, you can SolidWorks does not work on
MacBooks, right?
MacBook and Linux, but Autodesk Fusion does. So you can use Autodesk Fusion to do all the SolidWorks. You don't need SolidWorks, you can use Autodesk Fusion.
Okay, if you're having Mac, we can use Autodesk Fusion.
Yeah, when I recommend using Autodesk Fusion because it's much easier than SolidWorks.
Okay.
So I said SolidWorks because that is the standard software that has been used traditionally. But since I started using Fusion 360, it's free for all the students, the full version. And MATLAB also works on Mac and Windows. And ASU allows, with ASU, you can download the entire MATLAB. So the first assignment that will come to you is downloading and installing MATLAB and doing the MATLAB and Simulink onboarding course, because that you will need to do the assignments and then you'll finish it and then you will get a certificate. Okay.
So, do we need to do similar certification for SolidWorks as well?
No, SolidWorks certification is not needed. But you can do something like Autodesk Fusion. SolidWorks certification takes a long time. So I would just do MATLAB certification. So that is good enough.
Yeah, three parts.
What?
Total three parts.
People?
And under the SolidWorks certification has total three.
Yeah, SolidWorks is intense. I don't expect you guys to do SolidWorks. Any other questions? Yeah.
If you're using iPad to take notes, can we use it in the quiz?
Yeah, you can convert iPad notes to PDF, print the PDF and bring that PDF to class. Because unfortunately, iPad can connect to internet. I cannot block the internet. I could, perhaps if I bring my internet jammer, but that's not allowed by ASU. So, no, actually I have a jammer that we built. But we can't test here. We need to test it in a Faraday cage or anechoic chamber. Otherwise, FA or ASU won't like it. Yeah. Question. Will labs begin? Yeah, to be on the conservative side, let's say that labs will begin this Saturday. If not, I will let you know. Yeah.
One of the findings of the labs, can I get like between the other two? Because I'm busy in the morning. I have to look at
Saturday. You have class. Huh? So if you have a written justification that you are registered in this class outside ASU, you can bring it to us. We'll accommodate you in the other group. But once you are assigned the group, you cannot switch. Any more questions? Yeah.
So would we be needing any knowledge of SolidWorks or fusion?
No, no. All the knowledge that you need will be given to you. Don't worry. You will need the knowledge, but will be given to you. Yeah.
What about using MATLAB online?
MATLAB online won't work.
Like, I have MATLAB 2018, I believe, in my hard drive. That should work.
No, you have to install ASU given MATLAB 2024 with all the new toolboxes with 5.8 GB of software installed on your hard drive. Otherwise, you will come to me and then say my signal processing toolbox is not installed. So whatever you showed me in FFT is not working. So no, full blown MATLAB.
We use compilers for that.
Yeah, we can use compilers. MATLAB has explicit target. No, don't worry. As long as you are willing to learn, we'll teach you.
So we can use ROS.
Ah, Ross. It depends upon my good friends Kunal and Rajdeep. They know ROS 1, ROS 2, and so they will teach you ROS. But yes, you'll use ROS. Without ROS, you cannot do Cobot Labs. And this guy also knows ROS. So, any other questions?
What's the content of the in-person quizzes, and is there a limit to how much notes we can take?
Content of the in-person quizzes? I will let you know the day of the quiz. Those quizzes could be either in class here or they could be during the lab session in the lab, because right now we just have 1 hour 15 minutes. I can't give you half an hour quiz and waste my instructional time. So, but what I can do is you can do the lab and I can give you half an hour quiz at the end of the lab. What does that sound? Once again, I'm telling you, if you think this course is too difficult, drop it and go to MA 547. I said that twice.
So, 1% does not show, it doesn't affect us.
No, that person will lose attendance point. That person will lose lab points. Why would it affect you if you are present? Yeah, individual evaluation. Yeah, no teamwork.
what's the percentage of someone who are gonna miss a lab?
So, see, we are going to have at least 10 labs. Now, there are 30% to labs. So if you miss a lab, you will lose 3% already. Anything else? So MA 547, it does not have labs. It's just a very nice theory course. You come do MATLAB assignments and get a good grade using DH parameters. I will let you know. What you do is you go to myapps.asu.edu, search for MATLAB, download the MATLAB, go to MathWorks, create a MathWorks account, download MATLAB 2024A, I think, install the whole thing, and then there you go. Okay. And then you would do that 9-hour course on MATLAB by Saturday. MA 547. Yes. Say that one more time. Oh, no, your laptop should not, doesn't need to be super duper powerful. The only thing I don't know, so Kunal, are they, did you install Robot Studio on your? No, no, my cobot they can install, but what about the Fanuc robot? Did you install the Fanuc robot software on the?
Not that it's in progress, but for my cobot, it's.
Yeah, so are we gonna use sim building laptops? Okay,
I will provide more information on that.
yeah, so you will get that information on the very first lab, so I wouldn't worry too much about it. No other questions?
All the software that we would need, it's mentioned in the solution.
Yeah, you will get an email with the name of the software, installer link, account creation, and also the training and the quiz and certification that you have to upload to the canvas. Yes.
What software to use on the labs available on Mac? Or do we have?
MATLAB is available for Mac. Fusion is available for Mac. The only problem with Mac is sometimes the MATLAB compiler and XPC target does not work well. But at that time, you can use somebody else's. My cobot, Rajdeep, does it work on Mac? API and software. It's a Python, right? Yeah. Software. So yeah.
So will there be any midterms or final exams?
Oh, good question. There is no final. Yeah, there is no final exam. And there is no midterm exam. There are regular exams.
Master project.
Oh yeah, the project actually I'm thinking. Yeah, see, I want to teach something. But I will answer this question. Recently we have been working on this AR VR type of integration. So I'm thinking of assigning you a project where you will build a robot in a virtual environment so that you can use the MetaQuest 3 headset and actually interact with the robot. But give me a couple of weeks to formulate the project and I will announce it. So you'll have your own virtual environment. Yes?
Is Windows compatible with all the softwares that?
Yes, Windows compatible with all the softwares. Any other question? Okay, if you have questions, I can answer them at the end of the class. Now let me start. So first and foremost, I'm gonna start with a very basic and probably its concept is vectors. What is a vector? Vector needs direction and magnitude. So if I indicate AB is a vector, what it means? It starts at A and ends at B. Now please understand that if I want to denote a vector, I need a coordinate system. And in robotics 1, we use the right-hand coordinate system. In the right-hand coordinate system, this is your right hand. This is X. This is Y. And Z is coming towards you. X, Y, Z coming towards you. Please keep that convention in mind because we are going to look at 3D kinematics, which means your coordinate system can be anywhere in this 3D orientation. But always, thumb is X, first finger is Y, and Z is coming towards you. So you have X, Y, and Z. So this is going to be X, this is Y, and I'm going to show you which is Z coming towards like this. Now, there is the concept which is called as the unit vector. Unit vector has direction and its magnitude is 1. So I'm gonna indicate unit vector in x direction as I, unit vector in y direction as j, and unit vector in z direction as k. Now what does that mean? It means if I travel 1 unit in I direction, that is 1I. If I travel 2 units in I direction, that is 2I. If I travel 3 units in I direction, that is 3I. If I travel 1 unit in Y direction, that is 1I. If I travel 2 units in Y direction, J, correct, and 3 units in Y direction is J, 3J. So if I have a unit vector AB, I can specify that as maybe something like 3I and 2J. So because I need to go 3 units in the X direction and 2 units in the Y direction. So this point is 3I plus 2J plus 0K. Now please understand AB, which is 3I plus 2J plus 0K is not a unit vector. What it simply says that if I am at location A, if I want to go to location B, I travel 3 units in I direction and 2 units in J direction. Alternatively, I can go from A to B in the direction which is shown by this black arrow diagonally. This is called as vector AB. Now this is again not a unit vector. Why it's not a unit vector? Because the magnitude of AB is square of the first quantity, square of the second quantity, square of the third quantity, square root. So which is 9 plus 4, which is square root 13. So this is not a unit vector because its magnitude is not 1. But I can actually write a unit vector with this equation AB divided by magnitude of AB, which means I can say 3 divided by square root 13I plus 2 divided by square root 13J plus 0 divided by square root 13K is a unit vector. Now, what does this unit vector signify? It's extremely important to understand what this unit vector signifies. This unit vector signifies the orientation along the black arrow, which means it only tells you that you are orienting yourself from the I direction all the way to the AB direction. And if you travel square root of 13 in that direction, you are going to go from A to B. So this N hat is indication of the orientation. Once you combine this orientation with that magnitude, that gives you the full vector. Yes.
If in the z-axis the value is 0, so in this example, for z the value is 0, okay, do we need to include it in the equation or is it?
No, I just added that just for reference. Now, the point that I want to make here is, again, I will say this one more time because this is extremely important. A vector needs magnitude and direction. A unit vector has unit magnitude and it only indicates the direction. So if you take the vector and divide that vector by the magnitude of the vector, what you have is the unit vector, and unit vector represents orientation. If I give you the unit vector, then you know that in this unit vector means I actually orient towards that black arrow. That only tells you to orient, not to go forward. But if you go forward by the square root of 13, that magnitude, you are going to go from point A to point B. Everyone understood this? It's pretty simple, right? Now here comes the moment of enlightenment. Now, what I'm going to do is, I want you to think about this 3 divided by square root 13. Can you see that 3 divided by square root 13, this is 3, this is square root 13. And if I say this angle as theta x, do you agree with me that 3 divided by square root 13 is cosine theta x? Do you agree with me? Times I. Now, next thing, 2 divided by square root 13. Now, if I draw the same thing, and I can show it in multiple ways, but I'm going to show it to you like this. So this is 2 divided by square root 13. Do you agree with me that this is cosine theta y times j? Similarly, this guy is nothing but cosine of theta z k. And why did I write this cosine relationship? Because these are called direction cosines. And why are these called direction cosines? Because they indicate the orientation of the vector with respect to the principal axis of reference. Theta x is with respect to I. Theta y is with respect to j. And theta z is with respect to k. Everyone understood this? That's why these are called as the direction cosines. They give you the directional sense. Everyone understood this? All right. Next part. Now what I want to do is, I have this reference frame X, Y, and Z. Okay. So what I have is, I have this reference frame X, Y, and Z. And I'm going to call this maybe X naught, Y naught. This is extremely important. So don't write down, pay attention on the board. I'll give you time to write down. Z naught. And you will also have these notes and the video lecture. The concept is extremely important. So I have this X naught, Y naught, and Z naught. These three are mutually perpendicular. There is no requirement that you have to use the principal axis to be mutually perpendicular, but that makes our life easy. So for the robotics one, we are going to use right-hand coordinate system, and we are going to use mutually perpendicular axis. So I have these perpendicular axes. Now what I'm going to do is, I am going to rotate about Z. So when I rotate, I have, after rotation, I have x1, I have x1, I have y1, and I have z1. Now please understand, we are going to talk about the rotations with the direction. So whenever I say the rotation or an angle, curl your fingers, right hand fingers, in the direction of orientation. If your thumb is pointing towards the axis, that is positive orientation. Example, initial axis, this is the old x. You went to x1. Curl your fingers in the direction of orientation. can you see that your thumb, right hand thumb, is pointing towards the z axis? That means this orientation is positive. So for reference, I'm going to write this down here. So if the rotation is like this, is positive rotation. If the rotation is like this is the positive rotation. If the rotation is like this, that's the positive rotation. Curl your right hand finger in the direction of the orientation or the rotation. And if the thumb is pointing towards the positive z axis, that is positive. So check this out. So I'm going to call this theta z. And the same orientation here, theta z. Do you agree with me? Yes. Theta z positive. Curl your fingers in the direction of rotation. If your thumb is pointing towards the axis of rotation, then it's positive rotation. Imagine if you would have rotated downwards in downward direction, that would have been like this, which means that would have been negative rotation. Everyone understood? So check X. Curl your fingers in the X orientation. That rotation is positive. Curl your fingers about the vertical rotation. It's positive. Curl your fingers about the Z rotation. It's positive. Everyone understood this? Right hand, no left hand. Right hand. Now here comes the most important part. Now, and I need to write this down. This coordinate system is my old coordinate system. This coordinate system is my new coordinate system. So remember, x0, y0, and z0 is my old coordinate system. X1, y1, and z1 is my new coordinate system. So what I'm going to do is, I'm going to show you a cool trick, okay? And this trick, I want you to remember, because this trick is not given in any books. So what I want you to do is, I want you to draw perpendiculars. This is done in the books. So I want you to draw perpendiculars like this. And what I want to do is, I have this x1. Let me decompose this x1, just like what we have done here. I want to decompose this x1 like this and this. I want to decompose this y1, because note, y1 is like this in vertical and horizontal. So everyone understood about the arrow? So this is the resultant. This resultant is nothing but the summation of this first vector and the second vector. This is the resultant, which is the summation of the first vector and the second vector. Everyone understood this? Now I'm going to derive the rotation matrices. So the rotation matrix will be derived something like this. First and foremost, it's a matrix. You know what a matrix is? Numbers arranged in a tabular form. So first, this rotation matrix is the relationship between the new coordinate system and the old coordinate system. So let's write down our old coordinate system, x0, y0, z0. New coordinate system, x1, y1, z1. So your new coordinate system is x1, y1, z1. Old coordinate system is x0, y0, z0. And now what I want to do is, I want to fill in the blanks. So this one, oops. So I need to fill in the blanks. And what I'm going to do is, oops. So let's focus on x1. Projection of x1 on x0 is, do you agree with me? This is cosine theta z. Projection of x1 on to y0 is, can you see that is sine theta z? Are you with me? Projection of y1 on y0 is cosine theta z. And projection of y1 on x0 is sine theta z. Are you with me so far? Once again, I repeat, just think about it as right angle triangle. You have a unit vector in this direction. So projection of this guy 0x1 ox1 onto x0 is cosine theta z, on y0 is sine theta z. Projection of y0, projection of y1 onto y0 is cosine theta z, and projection of y0 y1 onto x0 is sine theta z. Everyone understood this? The only problem is the directions are reversed. What do I mean by that? If you look at this cosine theta z projection, it is aligned in the same direction as x0. Look at sine theta z direction projection. That is aligned as same direction as y0. Look at cosine theta z projection here. This is aligned with the y0 projection, but sine theta z projection is in the negative direction of x0. Are you with me so far?
Yes.
Okay, now we just fill in the blanks. Projection, so here is how we see it. Projection of new onto old, new to old. Projection of x1 on x0 is cosine theta z. Projection of x1 onto y0 is sine theta z. Projection of x1 on z0 is 0. Projection of y1 onto x0 is minus sine theta z. Projection of y1 onto y0 is cosine theta z. Projection of y1 onto z0 is 0. Projection of z1 on x0 is 0. Projection of z1 on y0 is 0. Projection of z1 on z0 is 1. So this is called as the rotation matrix. And this rotation matrix is given by the relationship R0 to R1, where R0 is the old frame and R1 is the new frame. Similar rotation matrices can be derived for the rotation about X and rotation about Y. And you can see those in the books. We are not going to use those when we do the forward parameters. We are only going to look at, so what you should remember is the rotation matrix about Z is cosine minus sine, sine, cosine, 0, 0, 1. This rotation matrix is called an orthonormal matrix. Why is it called an orthonormal matrix? Because if you look at the determinant of this matrix, so if you look at the determinant of this matrix, determinant of 0 R1 is equal to 1. And if you take each row is perpendicular to other row and column, which means if you take the dot product of each row and each column, it's going to give you 0, which means this is called as orthonormal. And if you are taking linear algebra course, I'm sure in the very first class they talked about orthonormal matrix, which means each row is perpendicular to other row. And how do you find that that row is perpendicular or not? You take a dot product and then you see that basically you get 0. So This is, now what does that mean? For an orthonormal matrix, inverse is equal to transpose. For orthonormal matrix, orthonormal matrix, normal matrix, inverse. So 0R1 inverse is equal to 0R1 transpose. What does that mean? Is nothing but it will be 1R0. So which means if you take the transpose of this matrix, so take this out. Right now, what this matrix is telling me that if I want to go from the 0th frame to the first frame, I need to use this rotation transformation. If I want to go from the first frame to the 0th frame, then I just use the transpose of this transformation. So this transformation is extremely, extremely important. Everyone understood this? Yes. You can derive similar transformations for the rotations about y and rotation about x. It will also include the exact same procedure of taking projections and mapping the new coordinate system or the new reference vector to the old reference vector. But as far as forward kinematics is concerned, we are just going to stick to the rotation about z axis. So this is the only transformation that you should remember. Everyone understood this? Any questions before I proceed further? Now we are going to discuss something called as the forward kinematics. Forward kinematics. Now what do I mean by forward kinematics? Forward kinematics means given the joint angles, find end effector position. What does that mean? Imagine if I have a robot with two revolute joints. We are going to talk about the robots. They either have a revolute joint or a prismatic joint. Revolute joint means something like this. So you have a revolute joint. This is, so you have a revolute joint, and then if you have a prismatic joint, which means that is like a cylinder. So something like this. So this is the hinge, which is called as the revolute joint. And this is the cylinder, which is called as the prismatic joint. The revolute joint is denoted as R, prismatic joint is denoted as P. And we are going to look at, or we are going to study three-dimensional kinematics. So what we are going to do is, if I want to show you a 2 degree of freedom robot, so let's start with something called as R robot. So this robot, and there are two ways this robot can happen. So you can have an R robot parallel to the first revolute joint is parallel to the second revolute joint. And how do we represent that robot? So you have this first revolute joint, and then what you have is you have this second revolute joint, and then at the end, the end point of the second link is called as the end effector. So this motor can rotate by theta. This motor can rotate by theta. And now I'm gonna give you some link lengths. I'm gonna call this L1 and I'm gonna call this L2. So, and we need to fix this first motor. So the forward kinematics problem is L1 and L2 are fixed. So these are the link lengths. So L1 could be maybe 50 centimeters, L2 could be 100 centimeters. So given theta 1 and theta 2, find position of end effector, which is EE, in x0, y0, z0. x0, y0, z0 is our reference coordinate frame. What that means is this is going to be my reference coordinate frame. If I call this as z, if I call this as x, so z0, x0, x, z, y is going in that direction. Please note, once again, I've shown my x in this direction, z in this direction, so my y will be going towards the board. Rule number 1, your z coordinate system or z vector must pass to the joint. If it's a revolute joint or prismatic joint, your z must pass to the joint. Next thing, let's go to the second coordinate frame. I'm gonna write this down as again z1. I'm gonna discuss these rules again, but there are 3 rules that you should keep in mind whenever you assign the coordinate frame. And we'll work out 5, 6, or up to 10 problems. So by the time we are done with it, we'll master this. So coordinate systems are extremely important whenever we set up a 3-dimensional kinematics problem. If your coordinate system orientation is incorrect, your entire problem will go wrong. Kinematics goes wrong, dynamics goes wrong, dynamics goes wrong, control goes wrong. So make sure that your coordinate system is set up properly before you even start solving for forward kinematics or even inverse kinematics. Always Z must pass to the joint. So Z0 should pass to the joint of the first revolute joint. Z1 must pass to the joint of the second revolute joint. So rule number 1, Z-axis must pass through joint axis. Rule number 2, XN axis must intersect Zn and Zn minus 1 axis. What does it mean? Now I will explain it to you. What does it mean? Now, everyone agrees with me that we have set up x0, we have set up y0, we have set up z0. Agree? We have set up z1. So naturally, I need to set up x1. So x1 axis must intersect z1 axis and z1 minus 1 z0 axis. So x1 axis must intersect z1 axis and x0 axis. Sorry, z0 axis. So I have 2 choices. If I choose this axis, to be x1, do you agree with me that this x1 intersects with z1? Do you agree with me? And this x1 also intersects with this z1. Do you agree with me? Now I could potentially have drawn, it's extremely important to visualize. I could potentially have drawn, instead of this being x1 here, what I could have done is I would have used this as my x1. Do you agree with me? Now this x1 intersects with z1, but it does not intersect z1 z0, because can you see that this axis will come like this. So if you see, it does not intersect, but it's kind of parallel by offset L1. So which means this will not be correct. So I cannot use this as coordinate system. I must use this as x1. And finally, I need to complete the triad. So I have x, I have z, my y needs to go in. Are you with me?
Yes.
Everyone understood about this coordinate system? Rule number 1, z-axis must pass through the joint. Xn must intersect Zn and n minus 1. And at the end, you have to complete the triad by right-hand coordinate system. Right-hand coordinate. Everyone understood this? Yeah.
Why is the positive extra on the right side? Like, I will be doing on the right side.
If I were to choose x1 onto the other side, which is in the direction of y1, then
No, not in the question of I1. Why is the positive extra on the right side?
I could do the positive x1 towards the left-hand side. But then what would happen is I need to use my y1 would come out. Sorry, y1 would come out.
Letting you the right answer.
That is fine, but then your position matrix will have a negative sign.
Ah.
So now the beauty of this is, please understand, my direction of x0, y0 and z0 is aligned with x1, z1 and y1. My x1 is in the same direction as x0. My y1 is in the same direction as y0. And my z1 is in the same direction as z0. Does it make sense?
What happens when the z axes are perpendicular and intersect themselves?
Yeah, we'll look at those cases when we look at R perpendicular to R. This is the very first problem. So I need to start with a very simple problem, develop the concept, and then we will look at the difficult problem, look at the exceptions, and then transferring the frame, adding in a intermediate frame, and so on.
So what if you turn the hinge like 90 degrees? Wouldn't the x be parallel to the old?
Yeah, the robot is going to turn, but we are going to set up the coordinate frame in something which is called as the configuration diagram. Configuration diagram means when my theta1 is 0 and my theta2 is 0. I would worry about non-zero theta1s and theta2 later, but I'm going to assign the coordinate frame in the configuration diagram wherein my theta1 is 0 and my theta2 is 0. It will all make sense. Everyone understood with this setup? Okay. Now, next thing is what I want to tell you is I want to solve forward kinematics problem. Forward kinematics problem in 3 dimensions, which means given the values of theta1 and theta2, what is the end effector position with reference to x0, y0 and z0. That is how the forward kinematics problem is set up. Everyone clear about this problem? The way this problem is solved is by formulating something called as, wake up, homogeneous transformation. So they took my class by the way. Pay attention, pay attention. So we have to form something called as the homogeneous transformation. Homogeneous transformation is given as 0h. So basically it is similar to the rotation matrix. So it's gonna be old. Then you have this big H, and then there is this new. And this homogeneous transformation is like a 4x4 matrix. This 4x4 matrix is decomposed into these 4 quadrants. The first quadrant is the rotation matrix. So R, old, and new. The last quadrant is 1, and this quadrant is 0, 0, 0. And in the last column, you have to fill in the blanks. First, second, and third. So these are the 3 blanks. And we already derived the rotation matrix. So what's gonna go here? So here, what you would write is location of new frame with respect to old frame in old axis. In old x-axis. And I will tell you what this means in lot of words, but once we do it, it's very simple. Here we would write same thing, location of one, location of new frame with respect to old frame in old y-axis. And here you will write location of new frame with respect to old frame in old z-axis. Once again, to perform the forward kinematics, you have to set up the coordinate frame, then find out the rotation matrices, and come up with this homogeneous transformation. This homogeneous transformation captures the rotation transformation and the translational relationship between the new frame and the old frame in the old coordinate system. So what this means is we want to find out where frame 1 is with respect to frame 0 from x0. So let me write this down and it will all make sense. So let's derive this homogeneous transformation for the first coordinate frame, which is 0, 1. And typically, since we are going to find out the end effector position, we add one more coordinate frame here. Bear with me, let me plug in my computer. So what I'm going to do is I'm going to add one more coordinate frame And for the sake of simplicity, there is no joint. I would just assume this to be Z2, this is to be X2, and this is to be Y2. This is the very first problem. So some of you may not understand this process completely, but we are going to work out similar problems for next 3 or 4 classes. So I promise you, by the time we are done with the forward kinematics, you will know this process by heart. So what I'm going to do is, I'm going to start with finding the rotation matrix. So rotation matrix is 0R1 is the rotation product of rotation matrix and something called as the projection matrix. Now let's look at the very first matrix that we have. So we have the rotation about Z. So the rotation matrix is the rotation about Z. Remember, what we have is we have the old coordinate frame, which is x0, y0, z0. We have the new coordinate frame, which is x1, y1, z1. Projection of x1 onto x0 is cosine theta 1. Projection of x1 onto y1 is sine theta 1. Projection of x1 onto z0 is 0. y1 is minus sine theta 1. Cosine theta 1, 0, 0, 0, 1. Are you with me? This is the same rotation matrix that we have. Everyone understood this? But there is a subtle difference. Now here, and this will answer the question that the gentleman asked, is this is the projection matrix. What does this projection matrix tell me? Projection matrix kind of tells me whether the coordinate frames are aligned or not. So I'm going to do some same thing. X1, Y1, Z1, X0, Y0, Z0. Okay, now I want you to look at X1 and X0. Can you see that X1 is in the same direction as X0? Do you agree with me? Yes. So I would write 1 here. So X1, can you see Y1 there is in the same direction as Y0? 0, 0, 1, 0, 1, 0. And Z1 is the same orientation as Z0. So 0, 0, 1. So here, the projection matrix is identity, which means multiplication with this rotation matrix does not change the sign. If I would have chosen the x value going in the opposite direction, there would be negative signs popping around here. Everyone understood this? No. In the first problem, I avoided that complication, but we will actually, in the next few problems, we'll do this. Once again, final rotation matrix is the rotation about Z multiplied by the projection matrix. Projection matrix gives you the relationship between the new and the old axis, whether they are oriented in the same direction or they are oriented in the opposite direction. So X1 is in the same direction X0, Y1 is same direction as Y0, Z1 is in the same direction as Z0. So I have an identity matrix. It means if I multiply, nothing changes. So which means my final rotation matrix, this is extremely important. And after this, I'm going to stop. 0H1. The first part is my rotation matrix, cosine theta 1 minus sine theta 1, 0, sine theta 1, cosine theta 1, 0, 0, 0, 1. And let's not forget this is 0, 0, 0. Now I have 1 over here. Now the next question is, what comes over here? Now, here, I need to, here at this location, we'll start here. I need to fill in the blank here. Here, the distance of frame 1 from frame 0 around about x0. So how far frame 1 is with respect to frame 0 along x0? L1. Now, everyone understood that is L1. That L1 answer is correct when theta 1 is 0. What happens if theta 1 is non-zero? It would become L1 cosine theta 1. You agree with me? So which means so if L1 cosine theta 1 is the answer here, L1 cosine theta 1. And this is positive. Why this is positive? Because check this out. This L1 is in this direction. So if I were to take the cosine component of L1, it will always be about x0. So it would be L1 cosine theta 1. The next part, which I want to talk about, is what happens here. Is now I need to find out the location of frame 1 with respect to frame 0 about y0. And that would be L1 sine theta 1. L1 sine theta 1. And I did not give you this distance, but I'm going to call this A1. And this distance would be A1. And this is the first homogeneous transformation. I'm going to stop here. In next class, I'm going to take the same problem from the beginning, apply the rules, set up the coordinate frame, find the rotating matrix, find the 0h1 matrix, then we will find 0h2 matrix. Actually, what I'm going to do is, I'm going to find 0h1, then I'm going to find 1h2, and the silence please. And the forward kinematics problem is nothing but 0h1 multiplied by 1h2, which is 0h2. And this is the solution of the forward kinematics problem. And we will solve the forward kinematics problem formulation by hand in next class. And then we'll go to MATLAB and solve the problem using MATLAB. So I will see you hopefully this Saturday in the lab. I'm going to stop here.